check. And link. What's this one? Uh, so does now the sound work?
Hello, hello. Test, test.
Test, test.
Okay. Good. Then let's start again, if no one's complaining anymore. All right. Then you will hear my introduction a second time now. I try to do it a bit shorter. So the motivation behind a Docker workshop is basically two things. Coming from the developer perspective, we got non-reproducible environments, meaning we have colleagues which are starting, which need to set up a lot of different things to get the environment started. And on the other side, developers don't always know their servers. So they have an application, but just throw the code over a virtual wall to the Umwerk systems team, and they need to host it somewhere without actually knowing how this code should actually work. So the separation of concerns is quite hard here, and there is kind of a solution or a approach to solve that, and that's called DevOps. That's where I stopped last time. There is a sentence which is, yeah, kind of the motto of DevOps that's called "You build it, you run it," and it's said that it is coming from the Amazon CTO. So they had this exact problem. They had a lot of different teams and huge problems because everyone was writing code, having different environments, and they needed to get more responsibility to their team. Um, so what is the difference in DevOps? DevOps is basically developer operations, meaning not only the operations team handles servers, but also the developers themselves. That means that when you build an application, you usually know best how to host it, or you should at least. And when you bring an application online and you have a bug in it, why is the operations team trying to fix it by putting more servers, more CPU power, or whatever behind it? Shouldn't be that something that the dev is doing? Um, and this way, you can also have this clear separation. So the operations team is handling the servers, really the servers, but all the code, all the deployment going to the server is the responsibility of the developer. That's something that is still heavily discussed if that makes sense or not. It might make sense for many teams, maybe not for all teams. But that's something we want to show you how we are doing it at RTL2. Because we are doing that more or less heavily in our projects at the moment. And we're using Kubernetes for this. So these are our two topics actually for today. It's Docker and a little bit of Kubernetes. If you want to get more into detail about that, we would need another bigger workshop probably, because that's a topic on its own. First, I'm going to talk a bit about the history, hosting methods. So when we're talking about Docker, we should first talk about what is the alternative? Where did we come from? So the easiest way to bring something on a server is a local installation. Local means it could either be on your really local dev machine or also on a server. That's what I also mean with locally. So let's take a PHP example. The same is true for Java, JavaScript, and whatever. So you need some web server for PHP, you need PHP itself. You probably have a MySQL server. You create the application, create some configs, and then you got it hosted wherever. That gets a little more tricky when you have a more complicated application. For example, when you want to host the old BTN and K50 apps, you also need Memcache, a Memcache extension, Redis. You have 7 applications with 7 configs. That takes a day or two to set up, probably. Okay, so that's kind of tricky already on the dev machine. So there is an alternative, which we already have in some projects, which are called virtual machines. I guess you all know what a virtual machine is. If not, just a short introduction. A virtual machine contains a full operating system. So it can be Windows, Linux, or something else, which is really running completely on a different machine. So you can have Linux on a Windows PC, Windows on a Linux PC, or the other way around. Yeah. Um, and that virtual machine can basically include one application, several applications, contain whatever you want. Um, and it is actually very abstracted from your host machine and kind of secure. There's some known some known bugs. So, but usually it's kind of safe. Yeah, I just listed some pros and cons. So virtual machines can be copied and moved. So you can just take your environment, give it to a colleague. You don't need to install any project code on your local PC. Also, not messing with your configs, which can get quite messy when you have a lot of projects. You can add all the configurations, all tools, everything you need. And the same goes for production systems. So also on production, you can in theory use virtual machines. The downside is virtual machines are heavy. That means they use a lot of CPU, RAM, and so on, because you basically really put a full PC on top of your PC. So when your virtual machine takes 2 gig of RAM and you have 8, then you can host at max 3 or maybe 4 of them, and then you're running into trouble. And you still got the same problem as running it locally. So you can install all your applications in there and it's fine. But after 5 years, no one has a clue what's actually inside that machine. So if you want to upgrade it, create a new one, then no one really knows what has been done to that machine. And then you do the same thing as you would do with a local environment. You try to figure out what has been installed and do it again and again. Not that cool. There was a solution for it called Vagrant. I guess you heard that already. That targets exactly those problems. So they are doing scripted virtual machines. Lovely word. Um, Actually, it is just a wrapper for VMware or VirtualBox Hyper-V. So it supports multiple VM technologies. And you have so-called vagrant files, which are Ruby files, which basically say take a virtual machine, install PHP, install Nginx, copy that project code over and to the virtual machine, and so on. And this way, it's reproducible. So plus and minus, it's basically the same as virtual machines, but it's reproducible. Problem is, yeah, it's still a virtual machine. It's still heavy. You still have multiple projects on one server. Think about my example with the BTN apps. When I have 7 applications there, and then I say, I want to upgrade PHP to version 7, and the other ones, sorry, and the other ones should stay at PHP 5.6, then I'm in trouble, kind of, because, sorry, not bad timing.
You okay?
So, sorry, I'm not back, more or less. So if you want to host multiple projects with different configs on one PC, this is quite tricky. And also setting up Vagrant is quite tricky. So people were looking for an alternative. One thing which we mentioned already now is Docker. The difference between Docker and a normal way of hosting something is basically this. You don't install all the libraries, all the settings on the host machine and all the apps next to each other. You bundle the apps with all the libraries into something called a container. Oh, what's going on? Sorry about that. So what does Docker do? Docker is an isolation of processes. A lot of people say Docker is something like a virtual machine. Yeah, what Docker does, it feels like a virtual machine. So you have an application which is separated from other applications, and it feels like they have their own virtual machine, but it's not. Actually, it's just some Linux features which are separating Docker processes from each other. So the processes, let's say you have 5 Nginx on one PC, they are still running next to each other like they would when I install them locally. But they are contained in a virtual file system with a virtual networking. So they are really this isolated that they think they are alone on the server, but actually they are still running like every other application. They include all the libraries they need, but no operating system. And that makes it actually extremely fast compared to virtual machines. Here is another nice graph, which I stole from the official Docker page. So normally you would have on the right side, you have the virtual machines. You see you have your normal infrastructure. That means your PC, basically. You have a hypervisor on top. That's something like VMware. Then you have the full guest operating systems, including your app. In Docker is basically a service running on your normal operating system, and then the applications are running on top of it. Oh, slowly. So, something you really need to keep in mind. Docker is no lightweight VM. It's not a real VM. You don't have your own operating system. You're still sharing it from your host machine. That also means you cannot run a Windows application on a Linux server with Docker, at least for now. There is no complete isolation. So there are some cases where a process can influence another process. They should be isolated, but it's not 100%. That's usually not a problem when you're just hosting your own applications, but once you have multiple customers on one system and the customers can deploy their stuff on their own, then it's getting tricky. That's what I meant with not completely secure. And now to Peter's part.
Okay, so let's see if we can do this without you disconnecting.
Hmm.
So if I do this,
Stop my
am
screen
I now
here.
able to see my screen or whoa?
Oh.
Yeah, I think it works. So yeah, my part is just let's go through a little bit of basics of Docker for developers. So what are the key benefits and the most common use cases where we use the Docker? So Docker as is its building blocks are usually the Docker client, which is nowadays it's either Docker desktop, or if you are running an older machine, this is Docker toolbox. Then we have Docker images, which are instruction files. How do you build a container? Then we have a next level Docker image file, which is Docker compose. And this is an instruction file which describes how your development environment is constructed, how it works, how it interacts with external world and other applications. And then we have some other cool tools which I would like to present to you, mainly Docker Hub, Kubernetes, and Kitematic. So yeah, as I mentioned, Docker client is a command line interface, how we interact with Docker. It is available on all three major OSs, which is Windows, Mac OS, and Linux. And its responsibility is mostly for pulling, building, running Docker images, setting up the volumes which are shared, setting up networks, and so on. It is really the main, how do you say? Yeah, the main CLI for Docker. How do we construct a Docker image? So we first write a Docker file, which is a description of our container. What is a container or image? So after we write a Docker file, we run the Docker CLI command Docker build, which produces us a Docker image. And this is, to compare it, it's like a burning a CD. So it does, by itself, it does nothing, but it's an instruction set for Docker. So when we run the Docker run command with this image, it starts up our Docker image and creates so-called Docker container. And the Docker container is a running instance of the Docker image, and it is available on a specific IP. And as we will see later in the example, we can set it to which ports this IP is responding to. Once we get a lot of Docker images ready and maybe lots of Docker, I'd say, various environments, then the Docker Compose comes in play. And this is just a plain like I said, plain text instruction set on how to produce these images and how to set them up properly so that they will be able to work with each other. Usually we provided Docker images names, environmental variables, and some other config options. And those configurations can be either in this Docker compose file, or we can put an external path to some file which is hosted on our server. This way we can ensure the security of some passwords for databases and so on to remain secret. And then after we run Docker compose up, it starts a multi-container environment where we can then replicate the production environment that is on our servers. Docker tools. So the main one is a Docker Hub, which is a repository for all the Docker images that are publicly available. Usually those images are supplied by the companies that produce the software we use, but it can be also some individuals or companies that are just using those images and need some custom setup for the environments. Kitematic is a GUI style explorer, as we will see later on, and it's just like easy way to interact with the Docker console. So even people who are not skilled in using CLI commands, they can still do the basics of pulling an image, running an image, and then interacting with the application and seeing what it is doing. Kubernetes, it's a product from Google, which is an open source container orchestration software. And it's mainly done as we grow our servers and applications and have lots of Docker composes. It's a really nice orchestrator tool where we can monitor what is happening with our apps, our containers, and memory, CPU consumptions, and all this fancy stuff. Last but not least is Portainer, which is a lightweight brother of Kubernetes. It's pretty much similar, so it helps us to orchestrate multiple applications, but it's not so, how to say, widespread. It's much more simpler and easy to manage. By the way, do you hear me? Probably. Okay.
We can hear you. I just need to unmute myself, and I was lucky that it worked.
Awesome. So for this live demo, how to say, I will be setting up a custom Angular application where we will generate a Docker image, and then we will publish it and run it. And afterwards, we'll have some fun playing with public Docker images and trying to set up Keycloak from Docker Hub. Okay, so if I go quickly through the pages, Docker for Desktop is our Docker instance that we install on our local machine, either be a Mac, Windows, or Linux. We can download it from this page. And after downloading and installing it, we will see that a Docker icon has appeared in our toolbar. And this is like this small Docker desktop. And here you can have some like Kubernetes instances locally or whatever. And from it, we can also access the Kitematic. Kitematic is, let's say, an explorer through the Docker Hub world. So here we can see all the available Docker images, and we can create one of them if we want and run this instance on our local machine without any hassle. And yeah, it's a really quick setup time. You can also run game servers on it. I think I saw a Call of Duty server available for it, and so on. And all those images are available on Docker Hub. Docker Hub is a repository. It's a public repository, but you can also install your private repositories if you are hosting some private Docker images with business domain logic inside of them, so you don't want to share it to the outside world. And it's pretty easy. So, for example, Keycloak, we can just search for it and get it from the JBoss, which is the official maintainer of this repository. Each Docker image is then properly versioned, so we can always set up our environments with explicit versions. So if we go to the demo, here I have an Angular application which was pulled from GitHub. I did slight modifications, but the main part is that here we have the Keycloak demo application, which runs, and then it will try to connect to the Keycloak service and authenticate the user. So the main part is the subcomponent, which has the out card, and then it tries to log in into our Keycloak. Usually, when we work with this, the normal workflow is that the developers run ng-surf and it's running the application locally. But once we are ready to deploy and build a production version on RTL2, we are usually using then the Docker images. And this is the example Docker file that we create for this application. So stage one, we take from Docker Hub, we try to search for node Docker image, and we say here an explicit version of 10.16 Alpine version, which means that it is a lightweight version. I need this image just to simply run npm install and npm run build. So the label means who is the maintainer of this Docker image, and as a workdir, I specify /app. So on the root of this Docker container, there will be a folder which is called application, app. And inside of it, I will copy the package.json file and package log file. So these two guys here. After this is done, I will run the command, which is npm install, and this will start pulling up the latest node modules, which are specified in the package.json file. This is just installing the dependencies of my application. And then after all the dependencies are installed, I run the copy command, which is copy everything to everything. So this is the root path, from where should it copy, and this is the destination file, this destination path. And this destination path is specified here as an /app. Why is this done like this? So why do I have multiple copies and not just a single one? It is because Docker under the hood is caching every command, so it's using layering. So if I copy package.json and package.json lock, and those files won't change, then Docker, next time I'm building the image, won't be running these commands. It will be just taking the version that he has in cache. And it's the same with the npm run install. Afterwards, I copy everything, like I mentioned, which means that the whole folder with the source and so on gets copied over into my Docker image. Which is a lie, because I have a Docker ignore file. And in this Docker ignore file, I say don't copy over node modules or git ignore, because I already installed them into my Docker image. Then it's the stage two. This next stage fetches another Docker image, which is ng-angs Alpine version, and I mount it to the variable cache volume. Then from the node image, as I specified here, so this stage one is called node. From node, I copy my app dist folder into the ng-angs HTML default folder. And afterwards, I also copy the ng-angs configuration, which we can see it here. Where are we? ng-angs. Here. So yeah, this is just a simple ng-angs configuration for Angular applications, which pretty much forward, it's just everything that comes to the root folder, just serve me the index.html file or 404. It also has some settings for gzipping and so on, but it doesn't matter for this kind of example. And what is still important is that here I specified that this ng-angs server should listen on the port 80. So if I go into my app component, I can run this command in my terminal and we'll see what happens. So what does it mean? Docker build with a T. This means the tag of the image that will be built using this file. I will be using this configuration file, which is angular app.docker file, which we can see here. And the root folder of the execution context will be app angular demo. So if we can check quickly, it will be sending the build context to the Docker daemon, which is just like everything that it needs to know about what it is building. It will be using label, and then we can see lots of commands using cache, because before I started this presentation, I was testing, and it already built those images. Thank you, Tommy. So then we are running npm install, and again, because nothing was changed in this copy package lock, it will be just using the cache result of the npm install, which means it will be copying over our node modules. Then we copy the whole application, and we start the npm run build. And in this case, it will now start the normal input for the Angular CLI, the build command, which is running. Here, step 9 of 12, we start with the nginx command. So from nginx alpine, we are copying over the dist folder and our config folder. So now we successfully built the tagged demo Angular latest. And if I want, I can now run this application through this command. So docker run will spawn our image into the container. The -p 3000 to 80 means that I want to map port 80 of my Docker container into port 3000 of my live server. If I run it, I will be able to slowly see that the Docker really spawned this instance. And it will be also visible then in my Kitematic. At the moment, it's still booting up, so yeah. It's dying. So while we wait for the keycloak Docker command to run, let's move on our next part of a job, which is the keycloak. So I go to Docker Hub and check the keycloak configurations. We can see that in the instructions it says, oh yeah, just run jboss keycloak and everything will be fine. Which is not really true, because we have to set up some environmental variables. So creating an admin account, we need to import a realm, and we need to connect our keycloak instance to a running database. So we could do all this through Docker commands, and this would look like me copying and pasting into the terminal the following commands. So first, I would need to create a network, which is a keycloak network. This means that everything that will be running in this network will be isolated from everything else in my machine. Then I would probably need to start the Postgres SQL, which says that, okay, Docker run, I will name my instance Postgres. It will be running on the network keycloak, and it will run the image from Docker Hub, which is Postgres. And for it, I will set up the environmental variables, which will be the database name, the username, and the password. After this is run, I need to spawn another terminal instance where I would be running the keycloak image. So again, it's the jboss keycloak image that is on the, where is it? It's on the Docker Hub. And again, I need to specify what is the database user, what is the database password, and set up the default user admin with some credentials, and also import the realms into my Keycloak application. And at the end, I would spawn my Keycloak app into the port 8080. So I would just map it from 8080 to 8080. This little guy doesn't want to run. Why don't you want to run? Let's see. So Docker PS is running the demo Angular latest image, the tricks. Okay. So we are running the application on localhost. And if I go back to this, it will probably say it's running. Oh, not exactly. Okay. So this site can be reached, but it worked correctly because in the application by default, when the user reaches the root of the application, he is being redirected to the localhost 8080, which is the Keycloak authentication page. So now let's just set up the last part. As I mentioned, if I would be doing the Docker command style, I would be needing to do this. But since we have the Docker compose, all this flags and info can be put into the one file. And here I'm using the Docker compose YAML. So from my Postgres instance, and this is the name of the image, which is on the Docker Hub, I create a Postgres service that has the volume, which is Postgres data, and it's mapped to the container folder of the Postgres data. I also have the environments variable set up here. And here we could do the build injection of the variables, or just instead of environment, we could pass the path to this environmental variables file. And same for the Keycloak. We define the service Keycloak. It's using the image from JBoss Keycloak, and it has all those passwords and admins and so on. At the end, we expose our Keycloak service to the port 8080, and we write that it depends on Postgres. This depends on part means that it will be waiting for the Postgres image to be ready before it can start the Keycloak service. And now if I go into my terminal and just write Docker compose up, it will start to create my Postgres image. It will create my Keycloak image, download them, and then boot into the database. And after a while, I think we should be able to see here that all the containers that are running. I really need a new computer. Yeah. No Cibara. Blah, blah, blah. Okay, so now it's just initializing the master realm with the user as I saw into the logs, so it will soon be alive. Yay, it's alive. So this is our Keycloak admin panel. Here we can log in with our admin user. And here we have our master realm. So let's say that we are an Angular developer, and all that the backend guys supplied us with was a Docker Compose file, which is this stats file, which sets up our keycloak environment, and then they gave us the client import and realm import files, which are used to describe the keycloak realms used in the keycloak configuration. So if we create a new realm, we can just select the file, and this is the file that the backend guys have sent it to us. It's in the code, and we want to use the realm import file. Okay. So we have created the realm, and the next thing that we need is for our realm in Keycloak, how it works, that we must specify who are the clients that are using this realm. So under clients, we can select the file again. It will be for our client application, where we can say that Umwerk demo is the application. Okay, this is all good. The only thing that we need to do it by hand is the scope. So this scope and all the clients can have just, this setting is not predefined. So at least for this demo, I had to do this view profile assign role to the client roles. Sweet. So if we now do again localhost 3000, we will be redirected to the Keycloak login page. And here we don't have a user, because if I try to log in with my admin credentials, it will be invalid username or password. And this is because the user has not been yet created for this realm. So the admin user is just on the master, but on the demo realm, we don't have a user. So we have to add dummy user who is enabled and safe. And since our dummy user is dummy, he doesn't have a password yet, so we need to reset it for him. Okay, so if we try now the other login, which is dummy, will be then authenticated and redirected back to this Angular application. And here, if we go then into admin console and let's say change some details for this user, we can see that after we refresh the page, we'll be redirected to the Keycloak back home, and then after we load the data, we will have his name over here. So all in all, this is the full setup of running an Angular app, which is dependent on the Keycloak configuration, which we spawned through the Docker Compose file. Yeah, I think this is it from my side. Now I think we can go back to you. Okay.
Okay. So just need to move some windows around here.
Oh yeah, and all the code for this demo will be also available later on Bitbucket. So if anyone is interested, we can take a look together and discuss any questions you would have around the setup.
So let's see if the screen share works again. I hope you see my slide again.
Do we? Yeah, I think we do.
Yeah. It should say Umwerk.
It does.
Okay. You see my orange Docker in production slide?
Yeah.
Okay. So we heard something about using Docker for development now. So I'm taking the next step to Docker in production. Actually, we do quite a funny thing at RT2. We don't do much Docker on development, Docker in development, but we do Docker in production. That sounds kind of weird, but it works quite well. The theory behind it, or actually the reason why it is like this at the moment, is that for at least 1 or 1.5 years, they couldn't install Docker on their local machines because of a bug in the Windows version they were using. Lovely. So we use Docker on the server, but not on the PCs. But it's slowly also changing. Um, so maybe we'll talk about hosting. That's basically, yeah, more or less like what I told you before, but not about installing software, more about really the server part. So, what did we have before or still have? Classical hosting. You probably all know it. You got a virtual machine root server or a shared web space somewhere. Um, you either upload your stuff via FTP, SFTP, maybe you use a git pull command somewhere, or when you're very fancy, you have a pipeline somewhere which deploys it for you, um, maybe using code deploy or some other tool. Um, there's nothing wrong about it. So good thing is, of course, system guys take care about it. Shout out to Tommy. um, so everyone knows how it works because it's quite easy. Yeah? You have a server somewhere, you put your code there, and it works. Nice. Okay. Accessing and debugging is easy. So you have SSH access most of the times. You go to the server and do whatever you want, and yeah, maybe it works after it, or you broke everything. Yeah, depends. You can change everything on the fly. So especially when you just have a FTP upload, it also has a advantage. You can just change your code while it's productive and then see if it works or not. Well, yeah, there are also downsides. So changes are not reproducible. I'm talking about a lot about reproducibility today, but that's actually a problem. When you just have an FTP somewhere and some devs are just modifying it, especially when you're working in a team, then after a year or two, you're asking yourself, okay, so I got a repo, I got a server, and there are 100 files changed. What is the current version? What is correct? What should be checked in? What not? Not that cool. That's better when you have a real deployment, but this shouldn't really be too much about deployment versus not non-deployment. There are other disadvantages. Something that I mentioned before: multiple projects on the same server. So when you have, let's say, a kind of a microservice architecture. So you have a Java service, some PHP services. They all want different versions, maybe different databases, have different requirements for connections, firewall security, and so on. That can get quite tricky when you just have some servers which you manually set up. And that's a lot of fun for the systems guys, but at the end, yeah, they know how it's set up. You know how it's supposed to work, and maybe at the end, no one has the full picture anymore. And also, updates are hard. So we got some servers which are running for 10 years, trying to update them. Can someone say what happens when you update them? No, not really. Can you just spin up a second machine and reproduce your changes there? Also not if you don't know what has been changed. So can be quite tricky. There is an approach which we already have for, yeah, I guess most customers, cloud hosting. Everything is in virtual machines. Hopefully everything is deployed via some deployment tool like our Bitbucket Pipelines code deploy or something like this. And the systems guys are doing a good job in using Puppet in that case to set up the machines reproducibly. So they at least know or should know which versions of different languages and packages and so on are installed there, and they can set up an identical machine, maybe with a newer PHP version you can deploy there. So there you already have it. The plus is it's reproducible now, finally. Still quite easy to handle. You can still use SSH, connect to it. Cloud hosting is also scalable, so you can spin up multiple machines if you need to scale. But it comes at a cost. So AWS is more expensive than a classical hosting, like Hetzner or something else. Um, that starts again. You have no real separation, so it's still just a normal server where your applications influence each other. And if you want to prevent that and say every service gets its own machine, then it gets expensive. If we would do it for RTL2, then we would need probably 200 small machines when each is running just one application. And that's quite expensive, especially if you want to scale them. So what can you do? Drink something. So what can you do? You can use Docker hosting. Docker can actually be run on virtual machines, on bare metal. It can run basically everywhere where you have a recent Linux. But when you would just install Docker on a machine, then you would start your Docker container there. But what if you need to scale? How does someone manage that? Yeah, so now you have one container, maybe you want more than one. Then at some point you need a second server. Then you would need to manually shut down some containers, start them somewhere else. How do they connect to each other? So that's a lot of configuration hassle, but there is a solution for it. And that's called a container orchestration. And there are actually some tools, but I would say the standard way at the moment, or the most used container orchestration, is Kubernetes. So what does Kubernetes do? It's a container orchestration, like I just said. It's basically an abstraction layer for containers. So you don't need to manually start them, stop them, move them around. You basically say, hey, I want 3 instances of that container running somewhere, and Kubernetes takes care of it. Kubernetes also takes all the network configuration, load balancing, auto scaling. It can handle DNS entries. So basically all the infrastructure you need around your container. Additionally, it got secrets management, cron jobs, and a lot of more stuff I cannot really talk about now, because that's something that would really need probably some days of workshop. So I just give you a rough overview. This is basically how Kubernetes is working. It's a little hard to understand, but you see you have the master node on the left and the worker nodes on the right. Usually you have 3 master nodes and at least 2 worker nodes, usually more. So we have between 6 and 12 worker nodes at RT2 at the moment. And the masters are actually there for handling the workers. So when you talk to Kubernetes, you give Kubernetes some command that it should spin up some pod, some container, or shut it down, then this goes through the master. And the master is controlling the workers. That's basically how it works. Another little graph which shows the components of how something is run. You see on the right side, the small thing, that's the container, 2 of them. The container is just a small part. So Kubernetes wraps your containers into some bigger objects. Around a container, you got something which is called a pod. A pod usually contains 1 container, but a pod can contain multiple containers. Too much contain in one sentence, right? So you got 1 pod with 1 container, or you can have 1 pod with 2 containers, or 1 pod with 3 containers. When would you want that? A pod is usually 1 application. That means that, let's say, a pod contains my Java application. That's 1 container. But when I have PHP, for example, on its own is not really usable. You need Nginx plus PHP. So you could, for example, take a PHP container together with an Nginx container, and they form 1 pod, and that pod is my application then. What you should usually not do is, for example, also take the MySQL server in there, because a MySQL server is usually not there just for 1 application. Could be, but it feels more like its own application. That's why that one would have its own pod. No slow. So the pod is inside a replication set, a replica set. A replica set basically says how many pods should run at the same time. The easiest way is it should be one pod running. That means that when this pod is shut down accidentally or on purpose, then the replica set starts it again. Like the name replica already says, you can say how many of them do you want. You can say I always want my application to run twice. That means that replica set takes care that two pods are running at the moment. That means that when one node, for example, that means really the physical hardware is removed, broken, shut down, whatever, then Kubernetes sees, okay, you wanted two pods, you only got one at the moment. I will try to find a place and spin up another one. That replica set, is inside a deployment. That's basically the object that we are usually working with. A deployment also has some more options regarding scaling and some other parts. And that one also contains, as far as I know, the image version. But that's something I would need to look up which part are exactly where. This one is using kind of inheritance. So you put everything in the deployment. The deployment is creating the replica set. The replica set is creating the pod, and everything is configured in the upmost level, so in deployment. What you also see in the picture is on the left side, you also have services and ingress. So why do you need them? When you have a pod running somewhere, that means that your Docker container is just on a server somewhere on a pod, which is not reachable anywhere. That doesn't help much. So you need to connect to your pod somewhere. The first thing you see, which goes to the pod, is the service. A service is something like an internal load balancer. That means that I get an external port for it. Let's say I got port 3000. And when I access that, then it's redirecting internally to one of my pods. That means that if I got 5 pods and 2 of them are down, no problem, because the service is redirecting it automatically to one of the still living pods. That also means that I got port 3000 somewhere out there, but I want port 80 probably, because I want my homepage to be accessible not on some special port. And that's what the ingress is doing. The ingress is actually configuring the external load balancer. That means that I can have something like virtual hosts on a classical hosting. So some domain port 80 goes to that container, another domain port 80 goes to another container, and so on. That's configured in the ingress. It is very tricky to understand when you hear that the first time, but when you did it 1 or 2 times, it's actually quite logical. I show you some examples of what we did, because that's a lot of theory now. I'll show you a bit about RTL2. So what was the situation at RTL2 before? We had quite a mix of technologies before. So the web team used Elastic Beanstalk as a service. Then we also implemented EC2 via code deploy there. They also have some old servers with an SFTP or still FTP upload. They have some kind of a weird FTP replication somewhere. Or no, it's actually async. We used EC2 with code deploy there, but we also still have an SVN deployment tool that Toby wrote back then. Yeah, great tool. And the servers are set up by a mix of employees. So the more recent servers are set up by Umwerk systems. Older servers are sometimes set up by guys from RTL2, or nobody even knows who set them up back then. So quite a chaos. And the problems we had are actually, different ways to host and deploy it. So the web team, for example, never really knew how to set up servers. So they didn't have any real deployment tool yet. So they just copied their stuff around or asked Umwerk systems. And didn't really know how to host their stuff. Um, we also had no really responsibilities. Like I said, some people just set up servers. I also started to clean up servers there. We found a server from 2012, which was running for what was it, 6 years then, producing around 20,000 euros in costs. We found that it was an applicant form for BTN in Köln, which was used for nearly half a year and forgot afterwards. So for one form, they set up an XL instance, by the way, with 4 cores, which was running idle for nearly 6 years after it. That's an example of why you shouldn't use a virtual machine and then forget about it. Um, so the same problem I already said before. System guys don't know the application. That is actually a very good example. So Umwerk Systems took care that this old servers got updates and got were still running and everything was fine. Yeah, but they had also no clue what was running there, yeah, because that's not their part. And on the other hand, the devs set it up somewhere, but servers are not their responsibility, so they didn't care, and that's why the server got forgotten at some point. And that's what I mean with many resources wasted. Yeah. Not only that, we also had some cases where we have servers which have 4 or 8 cores, which are idle 23 hours a day. But then in 1 hour a day, there are a lot of users. That's the TV business. Yeah. So you sometimes have really hard peaks, and then it's nothing again. And when you just have a normal virtual machine, you cannot really scale that easily, especially when it's a single application which cannot scale on multiple instances. So a lot of servers were idle all the time, and we tried to change that. So what we did was we unified the deployment pipeline with Shippable. That's something I will show you. Shippable is actually doing more or less what Bitbucket Pipelines does. So just compiling code, putting it somewhere. We used Shippable because RTL2 actually wanted to have something which can be installed locally because they don't trust cloud services so much for some reason, while we were building cloud services with it. What we did is using Kubernetes with distinct namespaces. That means we got 3 Kubernetes clusters now, which are distributed between teams. And actually, we say, for example, the web team has some namespaces for them. The app team, meaning us, we have our namespaces. We also have another Umwerk namespace and so on. I can show them later if you want. Umwerk system takes care of the Kubernetes clusters, so they set them up, make sure they are secure, they are updated, monitored, and so on. But at the end, deploying the stuff is part of what the team should do. So Umwerk system should be there to support it, but not really to get it running. That's the idea. So I brought you some screenshots of how it looks like. Starting at Bitbucket. That one looks quite old. That's because it's Bitbucket server, the self-hosted version of it, not the Bitbucket we are using. Inside Bitbucket, we got a plugin, which is called the Shippable Post Receive Hook. That one triggers whenever someone pushes something to our repo, a build at Shippable. That's probably a little hard to see, but I just wanted to show you we got quite some applications there already. And those are the steps, so from left to right. If I zoom in a little more, it looks like this. So we got a CI job, which builds the application and puts it on a Docker repo. That's this Docker Hub thing that Peter showed you before. There is also a private version called ECR hosted on Amazon, but it's doing the same. It's just hosting Docker containers, Docker images, sorry. So next step is that a so-called manifest is created. So we are putting some information in, like how much CPU does my container need, how much memory, and so on. Then there is a deployment step, which is putting it on Kubernetes. Then it's creating the service, and at the end, it's creating the ingress. So all the steps that you've seen before. Here's a lovely screenshot of ECR. So those are some of the containers that we have the images that we have at the moment. So the difference is that when I have an image and I run it, then it's a container. Before it's just an image. But I'm always mixing up those words. When they are running, that's how it looks like in Kubernetes. It's kind of wrong to say that's how it looks in Kubernetes because that's the Kubernetes dashboard. Kubernetes itself doesn't really have a UI. Kubernetes has an API, which can use from the CLI, API CLI, or you can have this so-called dashboard, which is also an open source project. There you see we got all the deployments. That's what I talked about before. So some words about stability. So every pod can be replicated. We don't really use that for all the pods because there are some pods where we say, yeah, if that one is gone for 20 seconds, no one really cares. But for all the high load production pods, we scale them up to 3, 5, 9 instances. Kubernetes also automatically relaunches failed containers. So if I have just one container, I don't really care. Yeah, when it's nothing which needs to be 100% available, because when it's down for some seconds, it gets restarted. That's it. Failed nodes are also automatically replicated. It means that when a node is going down, then the auto-scaling group of AWS spins up another server. Kubernetes sees, oh, there is a new node and reschedules all new pods to it. So this way, even if some nodes are dying in the middle of the night, no one needs to stand up. They will start again, pods will be put there again, and it will be up even faster than anyone else would probably be able to restart them. And a lot better than with a virtual machine or even, let's say, a bare metal. When your bare metal server goes down in the middle of the night, it won't heal itself. Yeah, someone will need to get up and, worst case, reinstall everything on it. Then something about scaling, which is quite interesting and also a topic on its own. Pods have a minimum and maximum resource requirement. That's called the requests and the limits. So if I have a pod and say it gets 200 milli CPU, that's 1/5 of a CPU, but it can burst up to 1 CPU. That means that when there is not enough capacity, so every pods which are on the server already took all the CPU with their requests, then Kubernetes will spin up another server. If there is enough space, it will be put on an existing node and it will be able to burst. So even if it has just a baseline of 200 milli CPU, in that example, it can burst up to 1 CPU. Same for memory. The minimum memory is always reserved. So if that one is hit, then it takes a new node and doesn't put it on an existing node anymore. And if the maximum is hit, then the process is killed. This is basically how resources are handled from Kubernetes. And additionally, there is a so-called horizontal pod autoscaler, which says one pod can scale inside its limits, but when it reaches its limits, then I'm scaling by starting another pod. So I can start with one pod, and when it's going to 50% CPU, then I'm starting another pod, another pod, another pod. This way, it's vertically scaling, and usually not on the same machine. It's usually when Kubernetes can do it, it distributes it over multiple machines. So that sounds quite expensive, but actually, the costs are not as high when you have quite some services. So what we had before were a lot of servers which were idle. So we had big machines which are just waiting for their time of the day, for their big 15 minutes when they would shine, but the other time of the day, they would be idle. And especially at RT2, that's quite interesting because that is kind of bound to the TV program. So the show which runs at 7 has the high load on 7, then runs the show on 8 and it has the load on 8. So if we put it all on one instance, on one Kubernetes cluster, then we have quite a distributed load because they are basically handing over the load from one service to another. Some little calculation example. If I have a small CPU which takes 200 milli CPU, then I could take 20 applications on a 4 CPU machine, roughly. If a 4 CPU machine costs $170 a month, then that's $8 something per application, plus the masters, then it's maybe 9. When I'm taking a small instance, then it's $18 a month. That's double the price. My application would have a full core then, but usually I don't need a full core when my application is just idle, and I cannot really burst then. So at the end, until now, we saved around 30%, not just with that, also by getting rid of unused servers and stuff like this. So Kubernetes at first brings the cost a bit higher, especially because you also need to pay extra for the masters, which don't host applications. But in the long run, when we migrated all services over to Kubernetes, then I guess we'll save half of our hosting costs till now. And we can scale better. So that's my big part here. Yeah, Peter, still here? Still alive?
Yes, I am. So,
Great.
yeah, continue.
I'm just taking a look at the chat if there are any questions from the viewers.
Yeah, I think now would be the perfect time for the questions. So if anybody has any, feel free to write them down and we can go through it. I think they are still answering the trivia question.
I'm also taking a look at it now. Already browsing Instagram.
So we have the first question, which is in what scenarios the containers don't make sense? Is this your PC? No.
Where containers don't make sense, I think there are actually some examples. Where I wouldn't use them is especially big applications which are not really scalable. At RT2, there is an example for with this Bitbucket. Bitbucket is very hard to set up. You need a lot of stuff around it, and it doesn't. Yeah, right. It takes basically a whole machine, so it takes 4 CPUs to run properly. If I cannot put anything else on the server anyway, then for me it doesn't really make sense to use it. Especially for legacy applications, it also might make no sense to migrate them. So for the intranet, for example, we never did it because we said it's just not worth migrating the old Drupal installation with all the crazy configs it has to a Docker container. If that would be done from the beginning, that would be cool, but moving now would probably take a week, and we will never get the money back from that probably, just because it's not that much cheaper in the long run. Peter, what do you think?
I'm thinking that my screen went dead. So yeah, it's the same for me. Like if you're having some small projects that are just starting up, maybe it would be smart to consider using Docker like throughout the whole production. But in case that you don't have it, it is then like weighing. So if you have some extra time on your projects, maybe it would be smart to migrate it just to achieve common unity at the end of the day. But otherwise, if there is no more like resources or so on to upgrade, and so it's hard to decide.
Generally, I would also say you shouldn't start with containers too early. Like when you set up a proof of concept, then I would still start doing it locally, just running it like this. But once you see that this is becoming a bigger project and you work on that for some time, or you need to get it hosted and already have a container environment, then I would go for containers. But also containers make sense when you have a lot of projects, a lot of applications. But when you, for example, just have one monolith application, which is running on one big server at the moment, then this doesn't make sense to be put in a container, because when you have one container running on one machine, then you don't need it. Containers are something for a microservice approach, especially, but also when you have some projects on it, even if it's not microservice. For example, for DSV, it would also be quite cool if you would have Datenzentrale 1 and 2 and Rennverwaltung and so on, all in containers. Then you could update PHP for one while you don't need to update PHP for the other application.
Yeah, which probably this would probably lead to my question, if I can run or do all those scenarios if I'm not hosting on AWS.
Yes and no. So basically, you can run Docker everywhere. If you want to use Kubernetes, that also works, but Kubernetes is probably not that good on a single server environment. So you should have multiple servers for a Kubernetes cluster. Otherwise, it's not that fail-safe as it should be. There are other alternatives like using Portainer, but that's something that we are discussing at the moment. Yeah, Dimitar is already throwing it in. There is Docker Swarm, there is Portainer, there are other ways to host Docker containers. I'm not sure where the future will go, because they already talked about discontinuing Docker Swarm in favor of Kubernetes. I would say that's something we should evaluate then, if it makes sense to use Kubernetes also on a small scale, or if we should find one or more solutions for that. But using Docker is anyway a good idea.
Okay, sure. I'm in, of course. Who pays? Yeah, it's gonna.
And the same is example for like WordPress applications that we have. So using the correct WordPress version, using the database and so on can be easily done through Docker Compose. And then on our repositories, we are just hosting strictly the changes to the code that we had. So like we can easily identify what has changed. And this is done then by using Docker volumes, so on.
I'm just reading the comment from my experience. Running big environments locally for development is not impossible. My laptop dies with 4 to 5 containers running. Do you try running bigger stuff on a single PC? So my PC doesn't die after 4 or 5 containers, but it depends how big they are. Yeah, so I think at RT2, the maximum we have are like 60, 70 containers on one instance with 4 cores. So usually it shouldn't be a big problem. It's a bit hard to say. I'm not sure how it is on macOS. Does macOS use VirtualBox as a virtualization? Peter, do you know that? Peter?
So no, it doesn't. It's going straight to the. I think it's not VirtualBox.
Yeah, because on Windows it's actually spinning up a Linux virtual machine on
exactly. But for the macOS, it's the same as on Linux.
Well, on Linux, it's running directly on the kernel, but does the macOS kernel have Docker support already?
Not sure.
Yeah, that's what I meant, what Dimitar is writing. So Mac and Windows are using some virtual machine in between. And the Docker toolbox is actually abstracting that away from you. It seems like there is some discussion about it.
So you're running Docker machine on macOS, which is then under the hood. I'm not exactly sure what it is.
Yeah, on Windows it used to be VirtualBox, and they switched to Hyper-V. I'm not sure on Mac.
That's why you use on Windows 7, Windows 8, and all the other systems. You are using the Docker toolbox, but now you use for Windows and Mac and Linux. It's always Docker Desktop. That are the two things I was talking about before.
That's the difference. Docker Desktop is using Hyper-V instead of VirtualBox. The only thing I could imagine, I had similar cases when I was using it with VirtualBox, that the virtual machine setup was very small. So it didn't get much RAM, CPU, and disk space. So maybe you're running out of something of that. But Dimitar is a fan of Linux now. Okay. Kafka and stuff. Okay, but Kafka itself also uses quite some power, right? How dependent is a Docker container on his host? Linux distribution, Windows version. Throw away my container when I update my OS. Now, actually, a Linux. Yeah, now it's getting a bit more complicated. There are also Windows containers, but let's talk about Linux containers. A Linux container contains basically all the libraries it needs. So you can run a Linux container which is using Debian on an Ubuntu Linux or the other way around. So it's not depending on the distribution, but it's depending on the kernel. So you might get into trouble when you have a kernel version which is not compatible with the one that was built when was used when building the container. But that's kind of a rare case. You don't need to throw them away. Usually it works, and it also works across systems. So when I build a container on my PC, it can also be run on the server, even if I build it on my Windows machine with the Linux virtual machine. What was the second question? Does my machine need to have MySQL installed for the container?
So this is connected to the tags, and as I wrote, you just change it either in your Docker Compose or in your Docker image file that you are using a different version of MySQL. And it should be really straightforward to switch between different versions of your databases.
Yeah, so there are actually different ways of doing it. So you could really include it in your application. So you could have a MySQL container shipped with your application container, but you could also go the other way and say you have a local installation and just connect to that from your container. So there is also no real best practice, I would say, because it also depends on the project. Yeah, Tommy, you shouldn't put multiple services in an image, but you can use Docker Compose to combine them. Yeah.
Yeah, so the stream is having a bit of a delay. I think it's 10 seconds, so bear in mind that. At least for the front-end projects and so on, I think it is a default, at least like to consider it in the start of the project. Is this feasible to use it and so on? Because if we are doing some maintenance on existing applications that we are not the owner of the code base, then using the Docker for this case is a bit iffy.
Okay. I think regarding the backend services, It depends on the project. I don't think that it makes sense for all the customers, especially those one CMS page somewhere customers are probably not the target group for containers or Docker. Maybe for the local installation, it might make sense, but still running a CMS in Docker doesn't have that much advantages. But especially for all our bigger IoT projects where we have a lot of services, I'm thinking about Hans Grohe, Skya, SDS, they should probably be put in containers, yeah, sooner or later. What the top arguments are for the customers, I would say costs, as always. Yeah, when I'm having one server per service and I'm going to 100 microservices and I spin up 100 virtual machines, that's just going crazy. And if you don't do that and put it all on one server, then at the other end, you need a lot of support from systems because they need to set up everything, make sure that this service is running there. And then you have trouble like, oh, my calculation service takes too much CPU. Can we move that from that instance to another instance? And then you're going crazy at some point. So when you're at that point, then you see that you save some costs in the long run. For our development, I think that's nothing that we can really sell to the customer. That's something that we should, when we want to do it ourselves, like investing some more time that every dev sets it up on his own when starting a new project. But that's actually a CTO decision, Philip. So we should think about in which direction it should go. Should every new project be set up in a Docker container, or at least have a Docker file available? I would say it's not really decided yet, but this is the first step to tell the team in which direction we are thinking, what we're already using partially. And yeah, feel free to also test it yourself. So if you got some time left in some project, just I know that's always the best gag, but hey, it's Friday, so a weekend is coming up. So if you're bored on the weekend, then try to build an application in Docker. If you need some support, I guess Peter and I and maybe other people from the team can help with that. Not on the weekend, I just heard. Okay.
No, it's fine on the weekend.
So yeah, maybe one thing that we didn't mention along this workshop was also onboarding new members on the project. So instead of reading through the wiki and asking people what is the setup, what is the environment, usually you can just look at the Docker Compose file that is provided to you in your code repository, and you can already guess what are all the services that are running this application, what is all needed to set it up properly, and you don't spend maybe 2 days of onboarding just for someone to set up the, let's say, PHP server with Apache, installing MySQL, adding MySQL admin, uninstalling MySQL because it was the wrong version, installing the right version, and then spending 5 hours because something is not working. And with this Docker Compose and so on, you can really fix those errors, and yeah, it's quicker to onboard than the new members.
I think I mentioned that, or at least I thought. Yeah, so that would be the key point. If you have everything set up in Docker already in Docker containers, then you can just give it to a new colleague and say, hey, spin up those servers, and they are ready to go. Philip, regarding structuring applications differently, there are some points which are tricky with Docker. One thing is, for example, a file upload. If I have a file upload on a normal server, I just save it on the hard drive and that's it. If I have a container, I need to mount it somewhere. That's still okay. But when I'm on Kubernetes, for example, I cannot just simply mount the local file system because it will be split up on different servers. So it gets more tricky then. There are ways to solve it, but sometimes it's easier to just use S3, for example. So yeah, there are differences, but everything is solvable. Do we get a server where we can run bigger environments locally if we don't want to run Linux? I actually think that it should run with the Docker installation on your Mac. Maybe we need to try what's the problem there. That's actually something where Tommy can help, right, Tommy?
He's ignoring it.
Yeah, or I need to write.
Tommy's writing.
Maybe. Oh. Did the presentation inspire you? Do I say yes or no?
No.
There is one option missing, which is eye closing.
Who's doing the polls? Philip?
Is there any other questions that you might have you would like to discuss, or should we wrap up for today? And I will wait for 10 seconds.
That's the delay of the stream, right?
Yep.
Yep.
So, I'm not sure if there are some helpful replies coming. Jenkins on Docker.
Yeah, so on the this application that I was showing, the Kitematic, there is a Jenkins Docker image which you can run on, and then it spawns you an instance of Jenkins server. But then configuring it and so on, it takes a little bit. But in theory, it works.
Hmm. Okay. If there are no more questions, I would say we close it for today. Thanks for joining, everyone. I hope you learned a little bit. And we'll probably then talk about the next workshops, if we have some, or in which direction they are going, maybe with some more participation for everyone. But that's probably a bit hard to set up. Kubernetes. The question is Kubernetes a topic which is interesting for the whole company? Because I think that's more just interesting for some persons, how to really use it, more in direction of the backend leads. Because I'm not really sure if it's interesting for everyone.
Well, for the front end, it's more like this, what Tommy said. So this basic configuration of containers and creating your application, and then spawning it. As for the backend developers, yeah, I think Kubernetes would be helpful.
Yeah, then I would say if you got some topics you want to hear about, you can write us. Yeah, try to collect topics and maybe find something.
Try the email and CTO.
Yeah, that would be an idea. So if you wanna, this workshop was actually presented by the robot. I love to say that. Sponsored CTO board, yeah. So
That's
you can
awesome.
write the CTO board at umwerk.com if you want to write us something, have some ideas, or also just notify us in Slack. Oops. Nope, that was
It's
wrong.
meine English.
That's kind of automatic already. Then let's close it. Have a nice weekend and see you next time.
Bye-bye.
Bye.
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 Bye.